Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss what is a page replacement, what is the need for a page replacement algorithm, what are the various page replacement algorithms are there such as first in first out page replacement algorithm, least recently used page replacement algorithm, optimal page replacement algorithm. All these concepts I will discuss in detail for you. So I request everyone to watch the complete video for better understanding. In non-contiguous memory allocation, the process is logically divided into pages. Usually, the main memory is logically divided into frames. The main memory or the RAM size is finite. Either it can be a 4 GB RAM or 8 GB RAM or 16 GB RAM. So, the main memory size is finite. But the process size may be more than the main memory size. Let's consider that your process size is 8 GB. One process is there which is 8 GB. But your main memory is 4 GB. But what visually we will say that whenever a process is executing, we will load that entire process into the main memory. That is what we will give an illusion to the user. But if you have a 8 GB process, how can you load it into a 4 GB main memory? But we will always give that illusion using the virtual memory. Meaning is that whenever a particular page is required on demand, the operating system will load that particular page if it is not available in the main memory. We are saying that process is logically divided into pages. Let's take that process P1 is there. It is divided into page 1, page 2, page 3, page 4, page 5. Now your main memory is there. Let's assume that it is logically divided into 3 frames, frame 1, frame 2, frame 3. Remember one important point. The size of a frame is equal to size of a page. So if you have 3 frames in the main memory, at max you can keep 3 pages only. Am I right? Now let's take that CPU is trying to access the page number 1, page number 2, page number 3, page number 4, then page number 1, page number 2 like this. Now whenever CPU is trying to access the page number 1, look at the main memory. Whether particular page is available in the main memory, it is not available. If the particular page is not available, we will say that it is a page fault. What is meant by page fault? When CPU is trying to access a particular page, if that particular page is not available in the main memory, then we will say that it is a page fault. If that particular page is available in the main memory, then we will say that it is a page hit. Okay. Now, whenever there is a page fault occurs on demand, because the CPU want to access the page number 1, as the page number 1 is not available, then we will do the swap in process. Meaning is that the page 1 is currently available in the secondary memory. From secondary memory we will load into the main memory. That process we will call it as swap in. Okay, we will have two process. One is swap in, another one is swap out. What is meant by swap in is bringing the page from secondary memory to main memory is called as swap in. So page 1 we will load it into the any one of the frame. Let's assume that we have loaded into the frame 1. Now CPU is trying to access the page number 2. Is it available? No, it is not available. So it is a page fault. Are you able to understand? So the CPU wants the page number 2. It is not there. So the page number 2 will be loaded in the main memory in frame number 2. Let's consider. Now CPU is trying to access the page number 3. It is not available. So it is a page fault. So it will be loaded in the main memory. Are you able to understand? Now CPU is trying to access the page number 4. Is page number 4 is available? No, it is not available. It is a page fault. Are you able to understand? Now what the operating system has to do? It has to load the page number 4 into the main memory, but main memory is full because main memory has only 3 frames. As the size of a frame is equal to size of the page, it can have at max 3 pages. Already 3 pages are there, so now I can say that main memory is full. If main memory is full, how can you keep the page number 4? Then only the replacement algorithm will come into the picture. Now the replacement is what? You have to find the victim page, which page you have to remove that particular page and then insert the page number 4. That is what we will call it as page replacement. Okay, removing the one of the existing page or swap out any one of the existing page and swap in the required page process we will call it as page replacement. Now one important point, we are saying that we need to identify victim page, meaning is that among the page number 1, page number 2, page number 3, which page you have to remove or which page you have to swap out, that depends on replacement algorithm. If you are using the first in first out page replacement algorithm, then which page was inserted first? Look at the existing pages 1, 2, 3. Among the 1, 2, 3, which page was inserted first? Page number 1 was inserted here, page number 2 here, page number 3. Which page was inserted first? Page number 1. So that page has to be swapped out, and then page number 4 will be swapped in. So that is the need for the page replacement algorithm, finding the victim page and then replacing the with the new page concept will call it as the page replacement algorithm. So in first out, the page which was inserted first will be swapped out first. If it is LRU, let's consider that. Okay, now it is okay. Page number 4, page number 2, page number 3. Because if it is LRU or FIFO, first time the page number 1 only will be swapped out. I don't want to confuse you. Now look at here. Now CPU want to access the page number 1. Is page number 1 is available in the main memory? It is not available in the main memory, so it is a page fault. If it is first in first out page replacement algorithm, which page will be removed first? Look at here, page number 2 was inserted here, page number 3 is inserted here, page number 4 is inserted here. Am I right or wrong? So which page was in first? Page number 2. That page will be removed and the page number 1 will be inserted here. So the pages 4, 1, 3 are currently available in the main memory. Now CPU is trying to access the page number 2. Is the page number 2 is available in the main memory? No. Again it is a page fault. Are you able to understand it or not? So which page you have to remove? The page number 3. Among the page number 4, 1, 3, look at here, lot of people will confuse, sir, page number 1 is inserted here, so that process, that page you have to remove. But look at here, page number 1 is inserted here, but after that we have removed whenever the page number 4 need to be swapped in. Am I right? So again page number 1 was inserted here, so page number 1 is inserted here, page number 3 is inserted here, page number 4 is inserted here. So which page was inserted first? Page number 3. That page you have to remove and swap in the page number 2. So finding the victim page will be done with the help of replacement algorithm. I hope you have understood the what is a page replacement, what is the need for a page replacement, and how the first in first out page replacement algorithm will work. If it is LRU, let me give an overview. Okay. If it is LRU, anyway in the coming videos I will discuss in detail with more example just to make you understand what is an LRU. Look at here, the page number access is 1, 2, 4, 5 is there. Okay, now look at here. Initially main memory is empty, so CPU is trying to access the page number 1. Is page number 1 is available? No, it is not available, so you will insert. Okay, you can insert any one of the frame. Page number 2 is available? No, it is not available, so it is a page fault. Page number 3 is available? No, it is not available. So currently page number 1, page number 2, page number 3 is available in the main memory. Now look at here, CPU is trying to access the page number 1. Is page number 1 is available in the main memory? Yes. If it is available, we'll say that it is a page hit. Now CPU is trying to access the page number 2. Is it available? Yes, it is available, so it is a page hit. Now CPU is trying to access the page number 4. Is the page number 4 is available in the main memory? It is not available, so there is a page fault. Whenever the CPU wants the particular page, the operating system has to load the page into the main memory. But the main memory is full, so you need to find a victim page, then swap out that victim page and then swap in the page number 4. As it is a LRU, least recently used page replacement algorithm, you have to look at the past references. Okay, now the existing page number 1, where it was accessed last time, here. Page number 2, where it was accessed last time, here. Am I right? Page number 3 accessed here. So among the page number 1, page number 2, page number 3, which one was least recently used? Page number 3. So that page number 3 you will swap out and swap in the page number 4. Is it clear? Now CPU is trying to access the page number 5. Is page number 5 is available? No, it is not available. So it is a page fault. So now which page you have to swap out? Page number 1. Why? Because page number 1 is referred here. Page number 2 is referred here. Page number 4 is referred here. So least recently page number 1 is referred. So you have to swap out the page number 1 and swap in the page number 5. So currently main memory is having the page number page number 5, page number 2 and page number 4. So that is about the least recently used page replacement algorithm. Now let me discuss about the optimal page replacement algorithm. Just I am giving any overview, but with more examples I will discuss in the coming videos. Let's take the page numbers 1, 2, 3, 1, 2, 4, 3, 5. Here you need, suppose let's take the 2. Okay. Initially main memory is empty. Okay. Now CPU is trying to access the page number 1. Is it page number 1 is available? No, it is not available. So it is a page fault. We will load, the operating system will load the page from, bring it from the secondary memory and load it into the main memory. That process will call it as swapping. Now CPU is trying to access the page number 2. Is it available? No, it is a page fault. Then CPU is trying to access the page number 3. It is not there, so operating system will load it. Now CPU is trying to access the page number 1. Yes, it is available in the main memory of frame 1, so it is a page hit. Now CPU is trying to access the page number 2. Yes, it is available, so it is a page hit. Now CPU is trying to access the page number 4. Is page number 4 is available in the main memory? No, it is not available, so it is a page fault. Are you able to understand? Now look at the optimal page replacement algorithm. As the main memory is full, the operating system has to load the new page. Some page you have to find as a victim page and have to remove it. Now which one is the victim page will depend on the replacement strategy. As we are discussing the optimal page replacement, we will look at the future references. Okay. If it is LRU, we will see the past references, but as it is an optimal page replacement algorithm, we will look at the future reference. Meaning is that now CPU want in future page number 3, page number 5. So CPU does not need page number 1 and page number 2. You can remove any one of the page and load the page number 4, because CPU does not need in future page number 1 and page number 2. So though any one of that page you can remove and load the page number 4. Now CPU want the page number 3. It is available in the main memory, so it is a page hit. Now CPU is searching for the page number 5. It is not available, so it is a page fault. So it will look the future references. There is no one, so you can remove any one of the page and load the page number 5. So this is about the optimal page replacement strategy. So I hope you have understood what is a page replacement, what is the need for a page replacement algorithm, and I have given an overview about the various page replacement algorithms such as first in, first out, LRU and optimal page replacement algorithm. I hope it is clear for you. If you still have any doubts related to any concepts which I have discussed, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. In the next videos, I will discuss about each replacement algorithm with proper example, and then I will discuss few gate questions. Then I will discuss what is the issue with the first in, first out page replacement algorithm. Then I will discuss about LRU with an example. Then I will discuss optimal. So I request everyone to watch the next videos for better understanding. Thank you for watching the complete video. Have a nice day.